Well, good noon everyone and welcome back to Data Structures Theory session. So we are continuing the linear data structure and the representation, the second unit, where we have to look at arrays, stack, queue and linked list. Within array, we have already gone through these topics like array representations, how we can declare, use elements, address calculation, pass arrays, either it is 1D or 2D. We have seen all those things. Even we have seen the sparse matrix and their mapping, 2D to 1D mapping, the storage structure and applications. Later, we actually moved towards stack. And inside stack, we have seen what is stack, how it works, few operations on stack like push, pop, peep, change, display, is empty, is full functions, right? Then we have seen application of stack, like we use stack to convert given infix expression to postfix or prefix. We have seen those algorithms, we have practiced that process with examples. We have also seen how we can evaluate postfix and prefix expressions using stack, right? So those are nothing but polish expressions. Prefix is equals to polish. Postfix is equals to reverse polish notation, okay? Another application we have seen Tower of Hanoi. That's a mathematical puzzle, and we have seen how we can solve this Tower of Hanoi using stack, because when we do recursion, it makes use of stack internally. And even you can say in Tower of Hanoi puzzle, those pole, those roads, source, spare and destination works like a stack, right? Few other applications we have seen like calculation of GCD, or maybe you go for decimal to binary conversion, you can also use stack there and so on, right? So that's what we have seen till now, and that's what your mid-1 syllabus is, which is starting from tomorrow. So once again, all the best for the all mid-1 examinations. But what we'll do today is we'll continue with our topic because we are lagging behind compared to other classes. Before we start, once again I'll clarify that look, in each and every topic I've explained how questions can be asked, what should be the marking system, and what you should write, right? So either it is 2 mark, 4 mark or 6 marks question, what you should write and all. So you can refer all recordings, previous recordings, and that will explain everything. Fine? So what I plan is we'll continue with the next topic now, which is nothing but queue. And inside queue, what we wanna do here is we will see how queue can be represented, what are the operations on queue, and then we'll see few types of queues. Now we'll start these operations with the help of simple queue directly. So we will start a simple queue with the understanding of normal queue, okay? And then furthermore, we'll go and we will see few other types of queues like a circular queue, a double-ended queue, a priority queue, and so on. And at the end, we will see few applications of queue. Now, these applications are not in a detailed part, but it's just a list of applications where you can use queue, okay? So this is what we have to cover under topic queue. Now, queue is very much simple one. Whenever anyone says queue, you have this picture in your mind. A queue outside the ticket window, or a queue outside somewhere, maybe form some kind of distribution process and all, right? So what is queue? It is nothing but ordered group of homogeneous items. In terms of computer and data, we have to say that it's a homogeneous item, same data type, okay? Same kind of data you are going to store in a queue. If it is number, it should be number. If it is text, it should be text. If it is process, if it is person, if it is let's say any other form, then everything is going to be in the same form, in the same data type. And furthermore, it is ordered one. who comes first, we need to remember. So it is ordered one, right? So elements may be inserted at one end and it can be deleted from the other one. That's what we do when we go for, let's say, movie ticket booking. No one allows us to stand in the first place, right? Because they comes first and they are ahead of us. We have to join that queue at the end from the last. So एक जगह से आप वो क्यू में इंसर्ट होगे. नाउ धीरे धीरे आगे के सारे लोगों को जैसे ही टिकट मिल जाएगी आपका नंबर आएगा. So the delete process starts from front and insert process starts from the end. आप लाइन में खड़े रहते हो लास्ट पोजीशन पे, लेकिन सबसे पहली टिकट मिलती है किसको? जो पहले खड़ा है. जैसे ही उसको टिकट मिलेगी वो लाइन में से निकल जाएगा. दैट्स द डिलीट प्रोसेस. एंड व्हेन वी जॉइन दैट क्यू, हम लास्ट में खड़े रहेंगे. वी आर बीइंग इंसर्टेड इन दैट क्यू. So insert at the end, delete at the front, which means the first element to be added will be the first one to be removed, and that's nothing but first in, first out, FIFO structure, right? So how do we create that functionality in a program? How we can create a queue so that we can use it, right? So one way to implement queue is we can have a data array to store your data, and along with that array, okay, we need two more variables called front and rear, which keeps the track of where is your front and where is your rear. So it's something like we take one array, okay, we call it a data array. Now insert operation is going to be done at what? One end. That's the last position. That is what? The rear position. And the delete operation can be done from the front position. From rear you are going to enter your data, and from the front you are going to remove your data. So we need front and rear, two more variables along with your data array. So right now, let's say if you are creating one queue which can handle integer numbers, so you will go for integer data array of some max size, right? And along with that you need front as well as rear, two more variables to remember the index value within your array. एरे के अंदर फ्रंट कहाँ पे है, रियर कहाँ पे है, वो याद रखने के लिए आपको दो और वेरिएबल चाहिए. जस्ट लाइक स्टैक के अंदर हमें एक ही वेरिएबल चाहिए था, टॉप वाज मैनेजिंग और टॉप वाज मेंटेनिंग दैट प्लेस वेयर वी शुड इंसर्ट एंड वेयर वी शुड परफॉर्म अ डिलीट ऑपरेशन. अब यहाँ पे इंसर्ट डिलीट दोनों अलग अलग जगह पे होते हैं, तो दोनों के लिए दो अलग वेरिएबल चाहिए. इंसर्ट रियर पे होगा, डिलीट फ्रंट पे होगा. So we need front and rear, two more variables which can handle those things. And combinedly, this is going to give you the entire queue. So we are going to create a structure. Struct queue. So you create a structure which has three members inside. One is the data array and other two are simple variable front and rear. Now when you change your data array may change its data type. So this may change. Data array, if you have integer data, it's gonna be integer. If you have character data, it's gonna be character. If you have float data, it's gonna be float. But remember, front and rear are always going to be integer because it only remembers the index value. And indexes are always going to be integer value. Right? So front और rear जो है वो integer ही रहेंगे. Data may change. One more thing. Now this is how we create a structure which contains data array and front rear positions or members. Now if you want to create abstract data type, an abstract data type, then what we do, we go for type def, by which we are going to define a new data type. So type def struct, need not to give any label here because in any way we are going to define it. So type def struct, then you are going to have your integer data array with some max size. You are going to have integer front and rear also, and you are going to define it as a queue. So when you define it as a new data type, abstract data type, then anyone can use it to declare a variable queue as a variable, right? So that's what we are going to do when we implement queue in a program. Just like stack, we also define a data type, new data type called queue. Well, so this is what the representation of your queue. This is how we can represent our normal queue. And to create that queue, we need a structure in a program, which will have one data array, two other variables to maintain front and rear positions. Well, so this is what a normal or a simple queue is. Agar ye simple queue hai, then let us see few basic operations on queue. Just like stack, we have few operations on queue. जब आपने stack बनाया तो आपने देखा था init operation, initialization, then insert और delete के लिए वहां पे था push and pop, right? And then few more operations like change, display, is empty, is full, and so on. Similarly here in queue, we may also have initialize operation, init operation. Now insert and delete in queue are nothing but in enqueue and dequeue process. Enqueue and dequeue. Well, you can also say insert and delete operation. Okay, insert operation and delete operation, because look, dequeue, dequue, dequeue is having two different pointers. Like let's say double-ended queue is also called dequeue. Double-ended queue is also called dequeue, and that's where you have ambiguity. अगर कोई आपको बोले कि dequeue करना है तो आप क्या बोलोगे, delete करना है या double-ended queue करना है? So that's why these names are now rarely being used. Whenever there is a queue, a normal insert and delete operation is how everyone explains. So queue के लिए हम सिर्फ insert delete बोलेंगे. फिर भी मान लो कि कोई आपको बोलता है enqueue करना है तो वो insert हो गया, dequeue करना है तो delete हो गया. Okay, and then there are a few more operations like is full, is empty, display, change operations and all. So there are a basic set of operations you have here which we can perform on a queue. And we'll start with the first one, initialization operation. We want to initialize our queue. Now what is queue? Well, when you define your queue, it's a structure, right? It is a structure which has three members, a data array and front as well as rear. And we represent that queue using just a normal array like this. This is your data array, and this is where your rear is, and this is where your front should be. But when you say this entire data array is empty, right, which has 0, 1, 2, 3, and 4 index values, right? So at that time, when your data array is entirely empty, what should be the place or what should be the position of your front and rear? That's the question. where these two pointers should point. Okay, something like this. Consecutively. Well, remember, when I say front is 0, what is the meaning of front? पहला आदमी कहां पे खड़ा है? That's your front, right? That's your front. When you go to ticket window, front क्या बताएगा? पहला आदमी कहां पे खड़ा है? If you say front is equals to 0, तो इसका मतलब तो ये हो गया कि 0 इंडेक्स पे आपकी पहली वैल्यू है. Do we have anything there? No, our data array is empty. If your data array is empty, do we have any data? Nothing. मतलब क्या हो गया कि वहां पे क्यू है ही नहीं, कोई आदमी नहीं खड़ा, टिकट विंडो पे कोई आदमी खड़ा नहीं है. Where is your front? आप फ्रंट को कहीं पे पॉइंट कर पाओगे? Nowhere. Front is nowhere. That's what we do with the stack. Stack के अंदर हमने टॉप क्या किया था? -1. Correct. So let us say front is -1. -1 is not a valid index. इसका मतलब ये हो गया कि पहला आदमी कोई है ही नहीं. Now at the same time, what should be the rear? जब आप टिकट विंडो पे खड़े रहने जाते हो तो आप देखते हो कि अच्छा ये लाइन कहाँ तक लंबी है, लास्ट आदमी कहाँ पे है, उसके पीछे आप लग जाओगे. लास्ट आदमी कहाँ पे है, उसके पीछे आप लग जाओगे. अब यहाँ पे कोई है ही नहीं तो आप कहाँ पे जाओगे? We call it, we assign rear also with -1. So if your front and rear both are -1, we say our queue is empty, and this is what our initialization condition. We will initialize our entire queue with setting -1 to front as well as rear. Now that becomes your init operation. अगर आप फंक्शन बनाते हो, then pointer पास करोगे, and then here you will use your queue variable to access the member, and that's all. That's your normal program function. It doesn't return anything, so void. Right? A very simple one. अगर आप इसका algorithm लिखते हो तो आप simple बताओगे. Step number 1, set front equals to -1. Step number 2, set rear equals to -1. Step number 3, return. Khatam. Right? So, well, initialization was very much simple one, but how about insert operation? What should we do if we want to insert a value? अगर हमें value insert करनी है तो हम क्या करेंगे? Well, let us assume that we have an empty queue right now. We have an empty queue. We have front equals to -1 and we have rear equals to -1. Now when I say that I want to insert a first value 5, where do we insert? In what place we are going to perform insert operation? Front और rear कहाँ पे insert करना होगा? Online students, front और rear दोनों में से हम कहाँ पे insert करेंगे? Forget about current case. In general, tell me, where do we insert? Correct. In rear. In general case, where do we insert? We insert in a rear. Last से insert होगा, आगे से बाहर निकलेगा. So we insert a value at rear place. इसका मतलब क्या हो गया? Whatever value you have, you are going to insert that in your data array at a rear place, data of r. अब हमें पता है कि अगर मेरा q वेरिएबल है then q points to data, q points to rear equals to a given value val. But what is your r right now? It is -1. What is your r at present? Your r is -1. Your rear place is what? -1. That indicates your q is empty. तो अब हम ये बोलेंगे कि अगर सबसे पहला नंबर आता है तो वो कहाँ पे जाएगा? 0th प्लेस पे. -1 से हमें r को 0 पे लाना पड़ेगा. So we can simply, what we can do is we can simply make r plus plus. So it's nothing but q points to r plus plus. We have increased our rear place by 1 and then we store a given value at that rear place. तो क्या हो जाएगा? अब आपका r जो है that becomes 0 and your given value is at 5. Right? तो चलो r तो जैसे ही पहला नंबर आता है आपने rear तो अपडेट कर लिया, still your front is -1. जब आपने सबसे पहला नंबर डाला तो आपको फ्रंट भी अपडेट करना पड़ेगा. भाई ये पहला नंबर था, ये सबसे पहला आदमी था जहां से लाइन शुरू होती है. हम जहां खड़े रहते हैं वहीं से लाइन शुरू होती है. कुछ डायलॉग है ना, याद करो. हम जहां खड़े रहते हैं वहां से लाइन शुरू होगी. वेल, व्हेन द फर्स्ट नंबर कम्स, जब पहला नंबर आएगा तो वो बोलेगा यहां से फ्रंट स्टार्ट हुआ. तो जब पहला नंबर आता है, रिमेंबर द फर्स्ट नंबर ओनली, सबसे पहला नंबर आएगा तो वो ये भी बताएगा कि यहां से लाइन शुरू हुई. तो हमें फ्रंट भी अपडेट करना होगा, लेकिन फ्रंट हर बार अपडेट नहीं होगा. ओनली वंस, जब पहला नंबर आएगा तभी फ्रंट अपडेट होगा. सो व्हाट वी कैन डू हियर इज वी कैन चेक if your front is -1 as well as your rear is also -1. Only in that case what you'll do is you will set your front equals to your rear equals to 0. Else you only update your rear place. So क्या किया? अगर पहला नंबर है तो हमने फ्रंट रियर दोनों को 0 कर दिया. So अगर वो पहला नंबर था तो फ्रंट और रियर दोनों 0 हो गए. And then we store a given value at 0th place. ठीक है? अब मान लो कि और एक बार मैं इंसर्ट करता हूं, इंसर्ट 6. तो क्या होगा? Let us see. सबसे पहले if condition, front equals to -1, rear equals to -1. well, front rear अब तो -1 नहीं है, वो तो ऑलरेडी अपडेट हो चुके हैं. सो if के अंदर नहीं जाऊंगा तो मैं else में जाऊंगा. else में जाके क्या करूंगा? I'll update only rear. so rear जो 0 था +1 करके 1 कर दूंगा. so now rear is pointing to index 1. वहां पे मैं नया नंबर डाल सकता हूं which is 6. okay, so this is where your front is and this is where your rear is pointing to. and जैसे ही आप नए नए नंबर्स डालते जाओगे तो आपका rear अपडेट होता चला जाएगा, लेकिन फ्रंट अभी भी 0 पे रहेगा. is that clear everyone? Online students, is this much code is clear in your mind? Okay, well, if that's the case, then let us insert few more numbers like insert 5, insert 6. Then I'll go for insert 7, insert 8, insert 9 and so on. Every time what am I going to do is I'm going to increase my rear. So जैसे ही 7 को insert करने जाऊंगा, rear update करके 7 insert करूंगा. Then next time rear update करके 8 insert करूंगा. Then next time rear update करके 9 insert करूंगा. So at that point of time your rear is pointing to 4, index value 4, that's where your last number is, and still your front is pointing to 0, that's where your front value is, sabse pehla number. Now current situation indicates your queue is full. So we can never directly go for insert operation. We have to check the overflow condition. Before we store a new value, we have to make sure whether we do have enough memory, enough space to store a new value or not. So before this part, okay, we have to write an extra condition where we are just going to check whether our queue has some empty space or not. Otherwise we say print overflow message, right? So what should be that condition? The current status, your front is 0 and if your rear is max minus 1, if these two are happening at the same time, right? So we say if your front is 0 and at the same time your rear is actually max minus 1, then we say our queue is full and we cannot insert a new data. Algorithm के लिए max minus 1 नहीं लिखोगे, आप simply max लिखोगे, right? So that should be the extra condition you have to check first, and then you may go for inserting a data. So that's the entire process. Now if we organize that entire process and we write algorithm, then this is how it should look like. So सबसे पहले हम क्या करेंगे, we will check for overflow. Now what is overflow condition? If your rear is max minus 1. If you do not check your front, it's okay, because हम कहाँ पे insert करेंगे नए data को? Rear पे. तो हमें सिर्फ rear check करना है. If rear is already max minus 1, आगे नहीं बढ़ पाएगा, तो हम बोल देंगे our queue is empty. Now this is a simple queue, okay? So simple queue के केस में आप सिर्फ rear check करो, चलेगा. So we say if rear is max minus 1, आप max भी लिख सकते हो, it's okay. Then queue overflow and you return. आप वहीं से return हो जाओगे. Well, if queue is not full, तो आप आगे बढ़ोगे. You will update your pointers. You are going to update your pointers. Now when we update a pointer, we first check कि भाई ये सबसे पहला नंबर है या और कोई. So we check if front is minus 1, if rear is also minus 1, then we make those two as 0. Front is equals to 0, rear is equals to 0. Otherwise, we simply increase our rear. Rear equals to rear plus 1. जैसे ये pointers manage हो जाते हैं, आप simple queue के rear में नए data को डाल दोगे. And then you return, you are done. You are done with insert operation. So what we do is, whenever we define a queue insert operation, we need one queue variable as well as we need a new data to be inserted. So there are going to be two parameters inside this function. A queue is your queue variable, x is the new data you want to insert there. And that's very simple insert operation. So have a look at this entire algorithm one more time, and if you have any query, you may ask. So very quick, if rear is max minus 1, queue is full. Otherwise, we check if front and rear both are minus 1, we make it 0. Else, r plus plus. And then you store your data at rear place and you are done. You're done with the insert operation. So that was insert. Now, how about delete? Let's also have a look at delete operation and then we will stop. So a delete operation. Let us assume that we do have few data inside our queue. What if I say I have few data like 5, 6, 7, 8? Well, in that case, my front will be pointing to this place and rear will be pointing to this place, where front is equals to actually 0 and rear is equals to 3. That should be your current case, right? Front and rear. Front is 0, rear is 3. Front is pointing to the first value, rear is pointing to the last value. And now what if I want to delete a data? Delete कहाँ से होगा? Delete कहाँ से होगा? Front, that's correct. So from where we are going to delete a value? It's very simple. Inside your data array, wherever your front is pointing to, you get a value from that place. आप एक वैल्यू वहां से उठाओ और उस वैल्यू को रिटर्न कर दो. Return that value. But remember, when you delete or when you retrieve that value, actually you are going to remove that value. अगर वो फ्रंट वैल्यू वहां से निकल जाती है तो आपका फ्रंट अपडेट होना चाहिए. Correct? Yeah, that's correct, Daksh. So what we need to do is we need to update our front also. What we need to do is we need to delete. Whenever we delete a value, we need to update our front. So we are going to update our front plus plus. So we simply update the front value and we return that value. So जैसे ही आप पहले डिलीट करोगे आपको 5 मिलेगा, फ्रंट इंक्रीज हो जाएगा. आप दूसरी बार डिलीट करोगे तो आपको 6 मिलेगा, फ्रंट इंक्रीज हो जाएगा. नेक्स्ट टाइम यू गो फॉर डिलीट, 7 मिलेगा और फ्रंट इंक्रीज होके 3 पे चला जाएगा. वन मोर टाइम इफ यू डू डिलीट ऑपरेशन, आपको 8 मिलेगा और फ्रंट प्लस प्लस होके कहां पे जाएगा? 4 पे. वेयर योर फ्रंट विल बी एट 4. अब यहां पे हमें दो केस मिलते हैं. सबसे पहला केस, अगर मेरा एंटायर क्यू एम्प्टी है, इफ फ्रंट इज -1, रियर इज ऑल्सो -1, तो मेरे पास कोई वैल्यू है ही नहीं. सिंपली आई कैन से इफ माई फ्रंट इज -1, तो मेरे पास कुछ है ही नहीं. वेल, दैट्स व्हाट द emptiness condition or underflow condition we are talking about. Before I get the value and return, I should check, do I have something to return? क्या मेरे पास कुछ है जो मैं return कर सकूं? So underflow condition before we perform this part, and that's gonna be if condition. So I can say if my front is already -1, तो मेरा queue खाली है. I can simply print underflow message. So that was one, and the other one that we discussed right now. 4 वैल्यू थी, चारों की चारों वैल्यू आपने डिलीट कर दी, तो फ्रंट प्लस 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 होते हुए कहां पे पहुंच गया? 4 पे. आपका फ्रंट पहुंच गया 4 पे, आपका रियर अभी भी 3 पे है. दैट्स नॉट पॉसिबल. फ्रंट के आगे रियर तो कभी रह नहीं पाएगा. दैट्स नॉट पॉसिबल. सो what we do here, if we say if your front is already greater than your rear place, then also you say your queue is empty. So either of these two, दोनों में से कोई भी एक अगर true है तो आपकी queue जो है वो खाली है. That's why we have or operation in between. बीच में और कंडीशन डालेंगे. दोनों एक साथ तो नहीं हो सकता, right? So this is what you can go for as a simple queue. अगर ये दोनों में से कोई केस है तो आपकी क्यू खाली है. आपकी क्यू खाली है तो आप कुछ रिटर्न नहीं कर पाओगे. अगर खाली नहीं है तो आप फ्रंट से एक वैल्यू उठाओगे Okay, you will take one value from the front, you increase your front, and you return that value. Now this is what your very much simple queue is. अब इस simple queue को आप थोड़ा modify अगर करना चाहते हो तो कर सकते हो. When you increase your front, at that time आप चेक कर लो कि आपका rear कहाँ पे. अगर front और rear दोनों same पोजीशन पे है तो इसका मतलब वो लास्ट वैल्यू है. और अगर लास्ट वैल्यू को आप डिलीट करते हो उसका मतलब ये हो गया कि क्यू खाली हो गई. जब भी क्यू खाली होती है आप फ्रंट रियर दोनों को -1 कर दो. स्टार्टिंग इनिशियल कंडीशन में लेके जाओ फिर से, तो आप अपनी नॉर्मल क्यू जो है उसको रीयूज कर पाओगे. अपने एरे को आप फिर से यूज कर पाओगे क्योंकि वो 0 पे चला गया. अगर ऐसा नहीं करते हो तो एक बार जैसे ही आपका रियर लास्ट में पहुंच जाएगा, डन. रियर कभी माइनस माइनस होता ही नहीं इस प्रोसेस में. सही है ना? रियर कभी माइनस नहीं होता. तो अगर आप उसको अगेन 0 पे नहीं लेके जाओगे, -1 पे लेके नहीं जाओगे, तो आपने एक बार अपनी क्यू यूज कर ली, that's gone. It's kind of a use and throw. अगर रीयूज करना है तो -1 पे लेके जाना पड़ेगा. So we'll see that later, but this is how we delete a number. So what should we do here? In a simple queue, look, I'm saying simple queue. अगर आप -1 पे वापस लेके जाते हो फ्रंट रियर को तो वो सिंपल क्यू नहीं है, इट इज अ मॉडिफाइड क्यू. ये याद रखना. ओके, सो इन अ सिंपल क्यू व्हाट वी डू, if our front is -1 or if your front is greater than rear, then you can say your queue is empty. You don't have anything to return. Otherwise, what you do is you take a value from front, you increase your front and return that value. Very simple, right? So that's the queue delete operation. That is what the queue delete operation is. अगर आप मॉडिफाइड क्यू की बात करते हो, अगर आप मॉडिफाइड सिंपल क्यू की बात करते हो तो आप क्या करोगे? यू विल गो फॉर इफ योर फ्रंट इज -1, दैट्स इट, फॉर प्रिंट अंडरफ्लो मैसेज. बिकॉज जैसे ही फ्रंट ग्रेटर देन रियर होगा आप उसको -1 पे उठा के डाल दोगे फिर से, तो एम्प्टीनेस कंडीशन आपकी सिंपल हो जाएगी इफ योर फ्रंट इज -1. If it is not, then in the else part, what you'll do is you'll take your data from front. You'll get a value so that you can return that value. But before you return it, you have to update your front. So what you have to do is you have to do f++. But not only ++, हमें ये चेक करना है कि अगर लास्ट वैल्यू है तो -1 करेंगे, अगर लास्ट वैल्यू नहीं है तो ++ करेंगे. So we go for one if condition here. If your front and your rear both are equal, तो इसका मतलब हो गया कि वो लास्ट वैल्यू है. अगर वो लास्ट वैल्यू है तो आप फ्रंट और रियर दोनों को -1 पे लेके आओ. Otherwise you simply increase your front. Now this is a modified simple queue where we reuse our entire array. Okay, a minor modification and you have a modified simple queue. अब ये याद रखोगे, अगर आपको simple queue पूछता है कोई तो you will go for this way. If anyone says modified simple queue or optimized simple queue, then go for the other one. Still, ये दोनों में से कोई भी लिख लो simple queue के बारे में. No one is going to say that you are wrong. Both are simple queue actually. दोनों में से कोई भी लिखते हो चलेगा, right? And that's our delete operation. So what we have seen is we have seen how queue can be implemented using array with two more variables, front and rear. We have seen what is queue. It's a first come first serve, first come first out, FIFO structure. And few examples of queues are nothing but a ticket window queue, line at a ticket window, or maybe some form distribution, or anywhere else. You have seen queues at multiple places. Wherever there is a need of first come first serve, there is always going to be a queue. And after that we have started few operations, looking at few operations like initialization operation, init, insert operation, and delete operation on simple queue. We'll stop here for today. In the next lecture, we are going to have a look at pick. Now I'm keeping pick in the next lecture because pick and delete both are same. When you do not update your pointers, it is pick. Like in next lecture में फिर से delete operation revise करना है. So that will be the pick operation. And then we'll go for a few more operations like change, display, is empty, is full, and so on. So that will be the part of our next lecture content. That's all for today. Thank you everyone. Thank you for being part of this session here. We'll stop for now. And you may leave if you want. If you have any query, you may ask me in a chat box.